you see the part I have highlighted in red? Does it make sense why that is a valid function? Because none of the points cross. You can draw a horizontal line anywhere you want to and a vertical line, and none of the points will ever be one-to-one.
What if
In the highlighted red part,
but we're always talking about that part, like the other side of the axis? I'm confused.
yes, we have to talk about negative pi halves rather than our positive pi numbers.
So we're only talking about one period and not the whole.
It's a half of a period.
Well, yeah.
So same thing with cosine. This is the cosine. Ta-da!
So that's half of the period,
Yeah. So then to recap, I'm going to move this down. Whoop. So what two... I'm going to get rid of this. What two quadrants is sine valid in? What two quadrants is cosine valid in? 1 and 2. And then just by looking at this picture, would you be able to tell me what two quadrants tangent is going to be valid in? The red highlighted part, like right in the middle.
1 and 3.
It's negative pi halves to pi halves.
So 1 and 4. So 1 and 4.
1 and 4. So tangent is both the same thing. So it's like one less thing to like memorize. You're welcome.
What about cotangent? Is it the same as cosine?
As tangent. The sisters are going to be the same thing.
Yeah.
So the inverse notation, of course, if you flipped your x's and your y's, and then your y and your tan negative 1. And then your domain and range. So what we just found out is that our range is negative pi halves to pi halves. So does everyone have their unit circles out and available? Because I would suggest relabeling your fourth quadrant radian values with the negative values that go along with them so that they're easier for you to switch between. Yeah.
Yesterday, it was either sine with the negative 1 or arc sine with the negative 1. We put arc
Arctan.
tan with the negative
1. Okay. How much more time does everyone need? Like a minute? I heard a couple uh-uhs. Does anyone need more time? Okay. I'll give you like 30 mental seconds. Okay, now we all good to move on. Hurrah! So much like yesterday, we have a couple of examples. Do we see how they're all positive? So between quadrant 1 and quadrant 4, which quadrant are we looking at for all of our positive values? Number 1. So obviously with tangent, it's not as obvious, you would say, for the values that you're looking at here, because we don't have a root 3 on our unit circle, right? But can someone list off for me the coordinate pairs that we have in the first quadrant? So Anna, can you give me pi 6?
Root 3 over 2 and 1/2.
And then pi 4 is obviously root 2 over 2. And then pi 3 is the opposite. Right? So then when we're looking at our values, we basically have to figure out where we came from. So tangent is, first of all, y over x, right? Right. It's y over x. And if you want 1, you want two values that are the same up top and down bottom. So which point are we at between our three options off to the right? It's pi 4. Now for number 8, you're looking to get root 3 over 1. So you want, that's where you're coming from. So what coordinate gives me a y value of root 3 over 2 and and an x value of 1/2? Anna kind of looked at me funny. Does anyone else feel that way too, where they kind of feel like I skipped some steps on my puzzle solving?
For number 8?
Yeah.
I don't know, this is just me, but when you put a fraction in a fraction, it gets confusing, so I usually just put the division sign in between them. So why are we dividing it by 1?
Because so root 3 or root 3 right here,
Yeah.
that's just like a number. And when a number isn't over a fraction, we assume the fraction to be over 1.
Mm-hmm.
So that's why I'm like, okay, so we need a root 3 over a 1, because none of our fractions over here, you have to get like a second part of the fraction somehow. So then I was like, okay, so all of my numbers are root 3 over 2 and then 1 over 2. And so I just kind of filled in those gaps, because whenever we do the keep, change, flip, those denominators disappear.
So you did root 3 over 2 divided by 1/2, is that what you did?
Mm-hmm.
Yeah, okay.
And then for number 9, in order to get a root 3 over 3, we had to rationalize our denominator to get there. So coming from the start, we had a 1 over root 3, because we had to do times root 3 up here and times root 3 down here. So you're working your way backwards on these problems. I'm I'm getting a little bit of like a blank stare moment.
Yeah. I don't know why it's not clicking for me.
Okay. So yesterday it was clicking because we could just literally go right to the unit circle and it was just right there.
Yeah.
The problem with tangent is that it's a fraction. So you have to do some work, which means that you have to figure out where you came from in order to figure out where you are. So there's a little bit more effort involved in these type of problems. Which is where I came up with, you take your original, what you were given in the problem, and figure out how to get back to this over here. How to get it to a fraction that we know. And so you kind of just have to learn
Because tangent is
y over x. So some of the things that we've seen before, we've seen this.
Yeah.
We see this pretty often. We just see a root 2. We've seen a root 3. So these type of things are going to be almost like good to memorize to figure out how you got to them. Because there's really only one way on your unit circle to get to those values, like when you have a tangent, when you have a cotangent. And so these coordinates will never change, right? These are going to stay stagnant. So how can we make it easier for ourselves to remember what they equal at the end of the day? Now, if trig wasn't fun enough, we get to do a little bit of algebra. Yay! Does everyone remember what this is? Fog and Goff and f of g of x. So you do this problem first, right? Or this one, and then you do this one second. So if everyone could just like real quickly give me a I want f of g of x. And if you don't remember, that's okay. We're going to go over in a second. But this is just kind of some background. Okay. So what we probably did a lot in algebra was you're given like f of g of 5. So you would plug 5 into g and then plug what you got in there into f. But when you just have an x sitting there, you just plug in an x where all the x's are. So we at first get 3x plus 7, and that is our new x. This entire thing is our new x. So then when we go to plug it into our f, we have 5, 3x plus 7 minus 9. Do we all remember that now that I went through it? And then you would do your adding and subtracting, your whole big thing. Okay. So now to do it with composite functions for trig. No, guys, no, we don't need to huff and puff. It's like actually so much fun. It's so easy. No, guys, I'm so serious. Okay, our cosine function is in what two quadrants? 1 and 2. Is 11 pi over 6 in 1 or 2? No. So we have to do some work. at 11 pi over 6, what is the cosine function? So now looking at the inverse function with our domain of 0 to pi, what value gets us root 3 over 2 for cosine? Yeah. So for all these functions, we have to do the inside first, right? So at cosine 11 pi 6, we go to 11 pi 6 on our unit circle. We find what the cosine value was. We ended up with a positive root 3 over 2. So then within our domain, which is only quadrant 1 and 2, where is cosine root 3 over 2? It's at pi 6. Because it's only going to occur once. There's only one right answer once you get to that. Yeah.
It's reflect.
Yeah. Reflectee. So now can someone, yeah. It's what's highlighted in green, pi 6. See how easy that was? Boom. Like, swag. Okay, can someone find 5 pi 4s? And tell me what the sine function is. So now within our domain, where is sine negative root 2 over 2? What was it? Yes. Did you say 7 pi? Or you say negative pi?
I said 3 pi over 4. Because, didn't you say, like, well, on the problem before it was, like, kind of reflecting? So
It is, but on our sine function, what two quadrants are we in?
1 and 4.
1 and 4. So you're looking for in the fourth quadrant, where is it negative root 2 over 2?
Oh, then 7 pi over 4.
But is 7 pi over 4 in our domain, or in our range?
So,
No.
negative
Pi over 4, which is why I said on your unit circle, you should really write down the negative values that correlate to those radians. So our final answer here is negative pi over 4. No. Okay, so now is negative root 3. So if we come back here, root 3 was at pi thirds. So a negative root 3 would be where? Negative pi thirds. So a helpful hint, if what you have in the parentheses, at the very, very inside of the function is within your range, and these two functions match, all you have to do does that make sense? Nope. Okay, so then where Anna told us that negative root 3 is at negative pi thirds. So tangent of negative pi thirds is what? Negative root 3. So when those two functions match and that original inside value was within your domain, you're just going to end up in the same place. So cut out the middleman, save yourself some work, and just recognize that those two functions basically cancel each other out. But up here we couldn't do that because why? Because 11 pi 6 wasn't in the range and 5 pi 4 wasn't in the range. So you have to do a little bit of work there to get it back into the range that you need it to be. Yeah, Ozma.
Like you know, like how work is for sine, it was negative.
Were you taking your test yesterday? Okay. I'm going to go back to this slide real quick. So the red is sine, the green is cosine, and the blue is tangent. So we decided in order for a function to be a function that you could only be in these two quadrants in 1 and 4. So I think Miss Bryant posted the video yesterday, so I would go watch that. So now cosine of pi halves, is pi halves in our range for cosine? Our range for cosine is 0 to pi. Hurrah! So all we have to do is write it down. Yes, Naya.
So if it's in the range, the answer is whatever is inside the box.
As long as, okay, so like looking at these next problems, those don't necessarily match. When those don't necessarily match, you have to do the work regardless. But if these are the same value, or if these are the same trig function, you just have to like kind of look at that value in the middle or at the very inside of the function and see, is it within the range or not? And then it's boom, bam, bam. Yeah.
I need more work.
Yeah. Well, we're just going to, for like 5 minutes, work on these. I'm going to do some of these though, so that we don't have to just like go right on our own. But I promise, like fifth block was like so impressed with how easy these were in comparison to the graphing. Can somebody find where on my graph cosine is 1? It's at 0.
Yeah.
Sine of 0 is what? Ta-da! That's the whole thing.
Wait, I gotta write that.
Okay, now I'm going to do number 2. Sine of pi halves is what? Sine of pi halves is 1. And where is cosine, the inverse cosine 1? Ta-da! Aren't those so much fun?
Well,
So we're going to prioritize the ones that don't have tangent.
that's understandable.
So 3, 6, and 7. Do those. And we'll have 4, 5, and 8.
Oh, if David understands this, it's gonna be easy test.
It's not hard.
You.
3 minutes, you got faith in us.
I do have faith in you.
Chat, hold up, break it down.
Okay.
Cosine.
If you're watching
Cosine of it, then you go look at the sine of it, I'm guessing. That's sine.
value for negative.
You
And
said-
then it was
wait,
somebody
you
added
said-
for page with one of the multiple
Wait,
Wait, so it's
with the coterminals. Yeah.
For science, it's quadrant 1 or 4?
Yeah.
Alright, yeah. So make me sound like a bad teacher.
You just laughing all the time.
Boom, you go to cosine. And then that's 1 over 2.
I'm probably.
That's your answer?
Cosine
Oh, so
is,
that'd be 1 over 2. Or would it be-
yes,
would it be
but you
five?
have to write cosine negative pi.
1 over 2.
You know what I'm saying?
Oh, cosine negative.
Because you've only done the one part,
Yeah.
right?
No.
So I'm talking about.
I went to look for cosine, and then I went to look for
Because
cosine.
you remember.
No, you gotta start in the middle, so where is it
I might
negative
be
3 over 2? You found it, negative pi thirds. So then it's cosine of negative pi thirds. And so at that same point, what is the cosine value? 1/2.
So I'll find the sign.
Don't give up on me.
Wait, can you check this for me?
Alright, Chad. So I'm about to
So this is
blow this big sky.
that's negative pi fourths, and this is negative pi thirds.
I'll blame this on Jake.
Because if you were going around this way,
It's all Jake.
that's
First for practice, blame it on me.
yeah.
Oh, bro, it's your fault, bro. Y'all niggas should show up yesterday.
Alright, so there's 3 right?
You just blocked up. Y'all don't flake, don't.
Who's all there? Not gonna see it.
Nobody.
No, so it's sine of. Ignore that for you, you just focus on this.
No!
Pi thirds. Right, I was just writing.
I know, I was, yeah, but-
I'm just hoping that it's the right combo.
Can this also be 1/2? Hold up, Chad. I'm cooking, let me cook, let me cook.
Cosine of negative pi thirds.
This is making my head hurt.
Right.
So
And
look, let me
then
cook.
you say
Hold on,
this
I'm
is
cooking,
at
then
negative pi
cooking.
thirds.
And we're cooking.
So you have these like, you see what I'm saying? Okay, very quickly, the one that everyone was doing. So if on your unit circle you were going to find negative root 3 over 2 for the sine value, where are you at? Quadrant 4. So you are at,
Wait. For the sign to be?
yes, you ignore everything that's not in the middle. So you focus at one thing at a time.
I thought the quadrant, the sign is negative root 3 over 2 is quadrant 3.
It is quadrant 3, but it's also quadrant 4. And quadrant 4 is within the range. Quadrant 3 has
Okay.
nothing to do with anybody. Okay, so then once we found that, that's how we got the cosine of negative pi thirds. Now go to negative pi thirds. Oh wait, you were already there. What is the cosine value of it? 1/2.
Oh my gosh.
And that's your answer. Yes, Ryan. No, because you were doing it the opposite way. So like down here, find where it's 2. It's not anywhere.
It's not. Then what do I do?
Not to find.
Oh, D&E?
Yeah.
Oh.
And then so like number 6, go to 5 pi 6. What's the cosine value? Negative root 3 over 2. Where is the sine function? Negative root 3 over 2. Quadrant 4, and what is that value? Negative pi thirds, and that's your answer.
Okay.
So that's why we did the algebra review, because you have to work your way inside out. You can't be doing too many steps at once.
It hurts.
I just don't get why is it negative 5/3? Yeah, that's what I was thinking.
because it's not, you see how this is the sign inverse? That means that we're working with that restricted domain.
The ones that you had.
Yeah. So we'll go over the rest of these on Monday. Okay, bye.